Hi, my name is Fatih Norshaza binti Farza from CDCS 110. Will be presenting our group project MAT183. First, I will start with introduction. Application of differentiation is a process of finding derivative or rate of change of a function. There are three techniques to solve differentiation problem. First is derivative of sum and difference. Secondly, derivative of a product function, the product rule. Lastly, derivative of rational function, the quotient rule. What is related rates? A related rates problem is a problem that involves at least two changing quantities. The rate of change, usually with respect to time. The idea is to find the rate of change of one quantity in terms of another quantity whose rates of change are known. The question should ask us to figure out the rate at which one is changing given sufficient information, all of the others. There are 5 steps in solving related rates. First, identify the rate of change that are known and the rate of change that is to be found. Secondly, find a formula or equation that related to the variable in step 1. In a geometric problem, this is aid by drawing an appropriate level figures. Thirdly, differentiate the equation. You will usually differentiate implicitly with respect to time. Fourthly, evaluate the equation. You will usually differentiate implicitly with respect to time. Lastly, solve for the value of the remaining rate of change at this moment. In application differentiation, we have 5 applications of differentiation. First, determining increasing and decreasing function. Secondly, Rolle's theorem. Thirdly, related rates. Fourthly, maximum and minimum problem. Lastly, mean value theorem. In this group project, we will focus more on related rates.
My name is Kimilia. In this part, I'll be explaining about our problem statement and how to solve the problem. One day, Alif was practicing his football skills in the small courtyard behind his house. He suddenly kicked the ball a bit too hard, and it sailed over his head, landing on top rooftop with a soft thud. Then, he quickly took his father ladder from the shed. He dragged the 15-foot ladder out and set it up against the house, making sure it was steady. So, the bottom of the ladder was being pushed towards the wall at a rate of 1/4 feet per second. How fast is the top of the ladder moving up to the wall when the bottom of the ladder is 9 feet from the wall? In this part, I'll be showing you guys how to solve the problem. So, there is a picture here showing that a boy is climbing to the rooftop of his house to get the ball here. So, let us begin. Before I start, I'll be doing the working by using 5 steps of problem solving for related rates. So the first step is to understand the question. So here, let me brief shortly about our question. So here, as you guys can see, x is equal to the length of the bottom ladder to the wall, which is this, and y is equal to the length of the top ladder to the wall, which is this. Okay, that's it. And we're also given that the ladder is about 15 feet. We also noted that the question also given us a value to when the bottom of the ladder is being pushed to the wall, which it change rate of 1/4 feet per second. This is the wall, this is the ladder. The bottom of the ladder was being pushed to the wall at the rate of 1/4 feet per second. Okay. Here. So the bottom of the ladder was being pushed to the wall at rate of -1/4, and then we need to find how fast is the top of the ladder was being pushed to the wall, which is y. So dy over dt is equal to y when x is equal to 9 feet. After that, after we understand the question, we need to find a formula or equation that is suitable for a particular question. And for this question, we'll be using the triangle that has right angle. The right angle is here. So, top ladder to the wall. And C is given, which is the length of the ladder, which is 15 feet. Right? What is the equation that's suitable for this kind of question? If we're similar with this kind of question, is equal to C. So the C is 15, right? Okay. After that, step 3, we need to differentiate both sides implicitly with respect to time, which is d over dt respect to time, x squared plus d over dt y squared. So 225. After that, we can just simply differentiate by using power rule. So power we bring to the front, and then power we bring to the front, and power minus 1. 2 minus 1 is equal to 1. So we just no need to write 1, just leave it there. So it's equal to dx over dt, same goes, is equal to 0. Right? After that, we need to solve for the y variable. So therefore, we need to bring the x variable back to the right. So 2y dy over dt is equal to negative 2x dy is already open. You can just simply. So as you guys can see, there are two variables here, which is x and y. So we need to find the value of y when the x is given. We substitute the x value into this equation. So we're in step number 4 now, which is evaluate and solve the equation. When x is equal to 9, and then y, make y as the subject, and 9 to the power of 2, we got 81, and then 81 we got 144. For the y value, we have, which is equal to 12. After that, we substitute the y value into the previous equation. Next step is step number 5, which is to solve for the value of the remaining, the rate of change. Just going to substitute. X is 9, then y is 12. And dx over dt, which is given from the equation, which is negative 1 over 4. Just substitute in, and just press the calculator, and we got 3 over 16 feet per second. That's the answer. We need to interpret the answer. Therefore, the rate of 3 over 4 feet per second. This equation shows us that the rate is increasing because the ladder was moving up, so the answer is increasing. If the answer is decreasing, it shows us that the bottom of the ladder is sliding down. And I have 5 steps that I obtained here. So that's all. Thank you.
Hi, my name is Safia Prasanna binti Mulyani from class CDCS 1102G. I am from group 4. My part will be the conclusion. So the conclusion is, the method used to determine the related rates was successful. Moreover, correct answer will be obtained by accurately determining the appropriate formula, which is the derivative of a product function and also known as the product rule. Lastly, by applying the application of differentiation method, we can manage to solve problems that happens in our daily lives.